Hello, this is Mr. Zanaletto. We're going to go ahead and review area of polygons. On the worksheet here provided, our first two questions are about parallelograms. That means that our area will equal our base times our height. And that's going to be for 1 and 2. One of the most important things with regards to any of the equations here, if you're talking about a base and a height, the height must be perpendicular to its base. And vice versa. I mean, it's both ways. Base must be perpendicular to height, height must be perpendicular to its base. And with regards to that, I mean, the diagonals also are perpendicular to one another, and we'll get to that in a few minutes. But right now, area equals base times height. That's what we're going to do. Now we're going to pull off that information. There's extra information in this picture. We're going to go ahead and look at these two measurements are perpendicular to one another. That should tell you then that's what's going to be making up your base, which looking at this picture, I would say this is my base and this is my height. So now when I go to actually calculate that, area equals base, 7 meters, times its height, 4 meters. And in the end, what do we get? We get our area equaling 28 meters squared. Looking at the other diagram here, it's a little more complicated looking, but really when you look at this measurement I look at as a height, and it would be perpendicular to what base? Well, this would be my base. Now it doesn't have a length on it, but if this is a parallelogram, opposite sides are congruent, so I can say that this is 1.4 inches as well as that side. And now these two, this would be my base and this would be my height. So now I go ahead and I go to plug that in. Area equals base 1.4 inches times my height 2.3 inches. Plug that in my calculator and I should get 3.22 inches squared. So area at the end is 3.22 inches squared for this parallelogram, and for this parallelogram it was 28 meters squared. Now moving on to triangles. Triangles, hopefully you remember, but if you don't, we give the information to you. Area here is going to be 1/2 base times height. And again, your base and your height have to be perpendicular. So when you see something like this, the only lines that I'm confident, that I'm sure are perpendicular to one another are this and this. Those two are perpendicular to one another. So when I'm looking at that, and I have my formula, I'm looking at this, I need this 16 feet to be my base, and then my height's going to be 5 feet. This other information is extraneous information, meaning that we don't need it. We need these two things. That's all we need. So now area is going to equal 1/2 16 feet times 5 feet. When you push all those into your equation, that's going to be 40 feet squared. Or put all those in your calculator. Area is going to equal 40 feet squared. That's how many, that's the area of this entire triangle. The next one, again, when I look at it first, this is my base, but I don't have a height that's associated to that base. So what do? I use the 12 meters. The 12 meters I like is using my base. And you can switch them, but that's what I think of my base. And this is perpendicular, so then I use its height. That is the height, and I have my base and my height. And again, now I'm going back to my equation. So when I plug those in, area equals 1/2 base, which is 12 meters, height, which is 5 meters. Multiply those together, and that should be 30 meters squared. Now, the next section is rhombus and kite. And what we're going to do here is, looking up here, that is area equals 1/2 diameter 1 times diameter 2. So that's the formula that I'm going to be using here. It's going to be area equals 1/2 diameter 1 times diameter 2. It can get a little confusing, but I think pulling this information off isn't too bad. Again, these are perpendicular, and these are my diagonals. This diagonal from here to here is 14 and 8. Put those together, you get 22 inches. And from here to here, you get the other diagonal, which is 16 inches. So there are my two diagonals, 22 inches and 16 inches. Their lengths. So now I have my information that I need to be able to put that in. Area equals 1/2 diameter 1, which I'm going to call 22 inches, and my diameter 2 is going to be the 16 inches. You can switch those, it's no big deal. When you start multiplying them, the order won't matter, and you'll get 176 inches squared. Now the last one on this side, and I'm going to take a little break after that, but on the last one, on the rhombus, on this rhombus, this was a kite, this is a rhombus. This rhombus, that arrow is indicating that this 3 feet is this length, which makes that whole thing twice that. That makes that 6 feet. And if this length is 5 feet, this whole length will be 10 feet. And those are the two lengths for the diagonals. Now just plug them into the formula, and you get A equals 1/2 10 times 6, 10 feet times 6 feet. When you multiply those together, you get 60. Half of 60 is 30, so you have 30 feet squared. That's the area of this rhombus. The area of this kite was 176 inches squared. I'm going to go ahead and break this up, so we'll go ahead and take a slight break and come right back with the second part of this, which will be doing the trapezoid composite figures, and then for honors, looking at the last instance where we take a regular polygon, area 1/2 times apothem times perimeter. So, thank you.